everyone, and welcome to episode 5 of Project StuG. As promised, after spending the last episode on the intricate MG34, this episode will be focused on the largest part of this project, the lower hull. This unit will form the core of the StuG and has to be accurate, square and strong enough to support all of the weight of the finished model. My StuG will just be static, so there's no need to design working suspension or a functioning drivetrain. My RC days are long gone. I'm going to use the same basic methods to make the StuG lower hull as I did for my 1/24 scale mouse lower and upper hulls. These were both laser cut in ABS and created a very strong, stable structure. I learned a few things on Project Mouse that should make the StuG lower hull a bit more straightforward, so here goes. Researching the subject is crucial, and there's no better way of understanding what you're making than seeing it in the flesh. This is one of the StuGs at Bovington. Sadly, most of the upper hull is obscured, but this late StuG and the cutaway StuG provide great reference material. The trailing arm suspension is fairly simple. It'll just be a matter of getting the geometry correct so the guides and bump stops line up with the suspension arms on assembly. Something I did notice on my visit was there's virtually no texture to the hull armour, which is one less thing for me to do, although I will be adding Zimmerit. The StuG III was based on the Panzer III and shares a lot of common components. Fortunately, I have a copy of the Panzer Tracts book on the Panzer III by Jentz and Doyle. As well as lots of useful photos, there are detailed drawings of the lower hull and many of the suspension components. This really helps clarify the suspension for me. Now I know exactly what parts I need to design and make. I'll still have to be careful though, as there are quite a few subtle variations between the Panzer III and StuG III, especially on the late G version. I designed the hull plates in my CAD software and started with the two side frames. The StuG suspension is offset, with the right-hand road wheels ahead of the left-hand set, so the two hull sides are different. This is reflected in the cutouts in the hull floor. The two sides are joined by plates which tab into the side frames. The internal cross plates will have to go in first to join the hull together, then the external plates followed by the floor. The locating tabs are all over length, so they can be filed flush when everything is bonded together, so there'll be less filling. With the final design set, I laid out the parts for cutting and export them as a flat 2D plan so that I can then trace the design for laser cutting. Before I start tracing, I need to know the cutting allowance. This is based on how thick the material is and has to be determined beforehand, otherwise the parts will be undersized and won't fit together. I've designed the hull to be cut from 4mm thick ABS and have to allow a cutting width of 1mm. With the exported image of my graphics software, I've carefully traced the outline of each individual part. You can see the 1mm wide outline just touches the edge of the part. I then need to reduce the line thickness to 0.001mm for the laser cutting software. You can see the outline is now bigger than the part, but hopefully that 1mm allowance will mean the parts come out the right size. I don't have a laser cutter, I don't have the space for one, and hardly ever need to use one, so I send my artwork off to a professional company. I use a company in London called Cut Laser Cut. They're very experienced, can cut a variety of materials, and are very helpful with advice when it comes to designing your project. Check out their website, it's a great resource for understanding the process and finding out the limitations of what can and can't be achieved with this process. There's a link in the description. With the artwork off for laser cutting, I turned my attention to the suspension. The drawings showed me how big the parts needed to be, but I still had to make everything fit together. The weight of the StuG would have to be taken through the wheels, suspension arms and the suspension mounts, so they'd have to be strong. I designed all the parts in my CAD software and tried to make the fixings as large as practically possible. I figured it was easier to make a strong part smaller than rectify a part that wasn't strong enough. The guide blades for the swing arms are handed for the left and right side of the hull, but there are 4 variants of the trailing arm for the StuG. There are left and right sides with and without mounts for the shock absorber. I decided that rather than make 4 different arms, I'd make one arm with all the relevant brackets, sort of a universal arm. I could then modify each arm as needed, by removing the parts of the casting I didn't need. I've used this method before, and it saves making a lot of moulds. It does mean reworking final castings, but there are only 12 arms, so it's not a lot of work. With all the parts designed, I prepared them for my resin printer. Currently I can only print small parts on my resin printer, and was relieved they all fitted on. Hopefully I'll upgrade to a larger printer soon, so I can print bigger parts. That'll mean larger models, and even bigger tanks. Cool! And here are some of the parts fresh from the printer, with all the supports still attached. Despite its size, my printer does turn out great quality parts. I'll be putting out a how-to video for resin printing, to show you how to get the best from your resin printer, so make sure you check out my how-to playlist. I decided to cast all the suspension parts in pewter, as they will give me plenty of strength and allow me to easily cast all the duplicates I needed. To do this, I had to initially convert the more delicate 3D prints into metal masters. After cleaning up the resin prints and milliputting areas where the supports had broken away the part, I made cold cure silicon rubber moulds. This is one of my standard processes, and you can see exactly how I do this in my how-to series. I only did this for the small parts, which I thought wouldn't survive the next stage of my production process. The castings from these moulds came out well, but needed a fair bit of cleaning up. At least they were fairly small, so it didn't take too long. And here's the finished masters. I needed to add a little milliput here and there, but we're all good. They're nice and clean and sharp. So, these are the finished parts I'm going to use to make a mould to cast duplicates in pewter. The main suspension mount has a removable tapered core plug to accept the suspension arm. The 2 small holes in the flat plate are to accept bolts to attach it to the hull floor. The suspension arm, wheels and other parts have all been tidied up with milliput. Everything's now ready for mould making. I'm going to make a vulcanized 9-inch mould for centrifugal casting. This mould was used to make the parts I needed for my mouse. I'll use this to plan the layout for the mould, so I can be sure I have room for all the parts. I'll try and make the mould as balanced as possible and lay out the parts paying careful attention to how the metal will flow. With the larger parts in place, the small parts fill in the gaps. It looks like I have just enough room. Traditionally, these moulds are made of tough rubber, which vulcanizes at 150 degrees C and 3000 psi. Unfortunately, the resin prints aren't too happy about that, so I use a softer low-temperature silicon rubber, which cures at 90 degrees C and 1000 psi. It's a bit like chewing gum. Let's see how that works out. We have success. After a few spins, the mould is dialed in, and I'm getting good castings. Casting circular objects can be difficult, as the forces at play can distort the mould, resulting in oval wheels, which can also be thicker on one side than the other. Not today though. You can see the removable core plug for the suspension works well, and the castings break away cleanly from the sprue. The sprue will just go back in the melting pot to be recycled. There's no wastage. And this is the full set of castings for the StuG suspension and road wheels. They're just raw castings at this stage and still have to be cleaned up and assembled. There's 90 parts here that need cleaning up, but for most of them, that'll have to wait till the next video. The suspension mounts need to be installed in the lower hull, so they need urgent attention. The hole for the suspension arm needs to be drilled out to 5.8mm in a pillar drill. As long as the part is well secured in the vise and I drill it out slowly, it goes really well. I used some tape to mark the correct depth of the hole. It really is quite a therapeutic process. With the main hole drilled, I drill a second 3.2mm diameter hole off centre to set the correct angle for the suspension arm. I have to be careful doing this so the drill doesn't skip. Again, just take it slowly and we're golden. Hold on, there's someone at the door. Perfect timing. Here's the laser cutting after only a few days. Let's see what we've got. They do pack very well. There's no danger of anything getting damaged. The ABS comes with a protective backing which I need to remove, but it all looks good. Now I've just got to put it all together. It looks like I allowed slightly too much for the cutting allowance, so the parts do need filing down to fit slightly, but that's no big deal. I've cleaned up all the inner parts which are now ready for their first full dry fit. I've also labelled the left and right hand side frames clearly, as the last thing I need to do is get them round the wrong way. That'd be a disaster. So far, everything's gone together well. The fit is really good. You can see the ends of the tabs sticking out beyond the frames for trimming off later. The mounts also locate tightly into the side frames, so we should be good. Now I need to glue them permanently in place with solvent before going on to the next stage. With the first stage glued up, the hull is now square and fairly rigid, so I can now add the outer plates. Again, these are glued in place with solvent adhesive. The suspension mounts have to be fitted to the floor before the entire floor unit can be attached to the main hull. And here they are, all in place. They were superglued into the floor plate, which was then inserted into the main hull. Solvent adhesive was used to join the ABS, and liberal amounts of superglue further reinforced the suspension castings. With all the glue dry, I decided not to drill out and bolt the suspension mounts to the hull from the outside with countersunk screws. I think the superglue will be enough to hold the suspension securely in place. I can now test fit the suspension arm into the hull mount. The offset locator on the back sets it at exactly the right angle, and with a set of road wheels drilled out to fit the axle, it's starting to look good. Now all I have to do is clean up the rest of the castings and fit them to the lower hull. Some parts, like the road wheels, will have to be primed before assembly, but that just takes a bit of forethought and planning. There's still a lot to do before the lower hull is ready for primer and paint, but I'm confident that at least I now have a good base to work from. In the next episode, I plan to get the suspension, road wheels and return rollers in place, and then add the drive sprockets and idlers. I'll also need to get the lower hull detailed as much as possible, with fixings and weld beads. I hope you're enjoying Project StuG. If you are, share with your friends and make sure you subscribe to my channel. So you catch my next video when it goes live, click on the bell icon. As you can see from my channel, I always have lots of projects going on, which I hope you'll find interesting. If you have any questions about Project StuG, just leave them in the comments and I'll get back to you. Thanks for watching.